Hello everyone, welcome back to my channel. This is our seventh video of Data Science Basic to Advanced course. In this chapter, we will be discussing about neural networks. In data science, a neural network is a computational model inspired by the way the human brain processes information. It is used to identify patterns, make predictions, and solve complex problems through a process called machine learning. Neural networks are core component of deep learning, which is a subset of machine learning. Now, neural networks are a powerful tool in data science for solving complex problems that involves large amount of data and encrypt data. The components of neural network involves neurons, layers, weight, activation functions, and optimization. Now, the neurals, these are the basic units of nodes or nodes in the network analogs to neurals in the human brain. Each neural receives input, processes it, and passes the result to the next layer of neuron. Layers. Layers involve three uh, sub layers. That first is input layer, the first layer where the data is fed into the network. Each neuron in this layer represent a feature of the data. Hidden layers between the input and output layers where the actual computation happens. A neural network can have multiple hidden layers, which is why deep learning models are sometimes called deep neural networks. Now, the third layer is output layer, the final layer that produces the predictions or classification result. Now, weights and biases. Each connection between neuron has a weight that controls the importance of the connections. There's also a bias term that allows the model to adjust the output along with the weights. These weights and biases are learned and adjusted during the training process. Now, activation functions. After each neuron computes a weighted sum of its input, an activation function is applied to introduce non-linearity into the model. This helps the network learn complex pattern. The last one is optimization. Gradient descent is commonly used to minimize the loss by adjusting the weights in the network, aiming to improve the accuracy of predictions. Now, there are four types of neural networks. First is first is feed forward neural network FNN, the simplest type where data moves in one direction from input to output. Specialized for image data using convolution layers to detect patterns like edges, textures, etc. Uh, RNN designed for sequence data such as time series or natural language where the output depends on previous input. Now, GAN consists of two neural networks, a generator and a discriminator that works against each other to generate new synthetic data. Now, application of neural network in data science. The neural networks are used in image and video recognition, anomaly detection, predictive modeling, and natural language processing (NPL). Let us now see the code for neural networks. So the neural networks are the powerful classes of models in machine learning used for a variety of tasks such as classification, regression, and more. In this demonstration, I'll show you how to build a neural network for classification using Python and a popular Keras library, which is part of TensorFlow. Now we'll use IRIS database, which is commonly used for classification problems. This task is to predict the species of the iris flowers based on four features. Now, the steps involves load the database, pre-processing the data, building the neural network, training the model, and finally evaluating the model. We will evaluate the model's performance on the test data. Now, let us run this code. And we have got this output. So this example demonstrates how to build and train a simple neural network using Keras to classify the iris dataset. Neural networks are very flexible and can be used for a wide variety of tasks, ranging from simple classification to more complex tasks like image recognition, natural language processing, and the basic example can be further expanded by experimenting with different architectures, optimizers, and hyperparameters. This is all for the video. Thank you for watching.